semua okay? Alright. Okay, Assalamualaikum and welcome back to Dynamics ECS 429. This is week 2 and today is our tutorial class. And for today's tutorials class, we are going to do this example which is available in the beer textbook. So today is 21st October 2021 and it's already 11:24 a.m. 24 a.m. Okay, so I'm assuming everybody has copied this question and draw the diagram in their textbook, in their notebook.
Yes.
Yes? Okay,
Yes.
please respond, yeah? Okay, good. All right, now let me read the question to you together. Yeah? Collar A and block B are connected by a cable passing over 3 pulleys. So there are 3 pulleys here, okay, which is pulley C, pulley D, and pulley E. So there are 3 pulleys. Okay, these are pulleys. Okay, C, E, and D. Okay, is attached to a collar which is pulled, and while D is attached to a collar which is pulled downward with a velocity of 75 millimeter per second. So collar D ni dia pull downward. So dia turun bawah with a velocity of 75 millimeter per second. So as you can see, it says here it is pulled down. So if we assume anything that is going down positive, whatever answer we get negative means it is going up or down. I cannot hear you.
Down.
Up.
Up or down?
Down.
Up.
Salah. Okay, right now, pulley D is going downwards with a velocity of 75 millimeter per second. So kita dah assume ni positive. So if later on we get a velocity to be negative, do you think it's going down also or going up?
Up.
Up. Okay, you get it, eh? Understand? Don't always assume anything going down is negative. Eh? It is based on how we assume in the earlier part. Okay? All right, now at t equals to 0, collar A starts moving downward from K with a constant acceleration. So K ni, collar A ni, collar A ni dipanggil collar, apa? Collar, okay. So collar A ni is moving downward from position K with a constant acceleration and no initial velocity. So collar K ni ada constant acceleration. So constant acceleration ni berapa?
0.
So bila apa? Sekejap constant acceleration with no initial velocity, knowing that the velocity of A is 300 millimeter per second. Okay, bukan 0. Okay. Dekat sini dia ada kata dia ada constant acceleration. Maksudnya apa? Kat sini when it says constant acceleration, maksudnya kita kena guna the basic kinematic equation using yang ada constant acceleration, which is V equals to V naught plus ACT. Yes, S equals to
S naught plus B naught T plus 1 to ACT square.
Coba I pula tak hafal pula. Okay, S naught plus S equals to S naught plus
V naught
T plus
1
1 over 2 ACT squared, and then V squared equals to V naught squared plus 2AC S minus S naught. Okay, those are the, okay. And no initial velocity, knowing that the velocity of collar A is 300. So velocity of collar A, okay, that is the velocity of collar A, and it passes through point L. Okay, now determine the change in elevation. Okay, determine the change in elevation, the velocity and acceleration of block B. So dia nak change in elevation. So change in elevation means xb minus xb naught. This is the change in position. Maksudnya the final minus the original. Okay. And then it wants the velocity of block B. And lastly, it wants the acceleration of block B. So it wants all these information. Okay. All right. Now, so it wants the change in elevation of block B, the velocity of block B, and also the acceleration of block B. So this is block B. Let me color the block B in green. So it wants all these value. It wants XB, VB, and also AB. Okay, all right. So how are we going to do this? Okay, now, if you look at this question, we have to understand which particles here is causing motion. So how do you know which particles is causing motion? It means it is moving, right? Okay, now, is color A having motion?
Yes.
Okay, all right, good, yes. So my question here, which particle is causing motion? So is color A having motion? Yes. Okay, now is is pulley C having motion?
No.
No. Okay, no. Why no? Because pulley C and pulley D is fixed.
Fixed.
So it's not going to move. It's gonna maintain the position. Now is pulley D going to cause motion?
No.
Why no?
Yes.
Now pulley D has a constant has what? Has a constant velocity going downwards. So it means pulley D can go down. Understand? Can you imagine this diagram? Let's say you pull if let's say pulley D goes down, the string of the string attached to pulley D will be longer, right? And what do you think will happen to uh, uh, what do you think will be happen to block B? Will be shorter. When something is pulling down, the other side will be shorter as an assumption. You understand? So this pulley D can go up and down. So it has motion. Okay. So which particle is causing motion? Collar A, because collar A can go up and down. Pulley D can also go up and down, and block B also can go up and down. Are you okay, guys? So these are the three things that can move. Okay. Collar A, pulley D, and block B. These are the only three things that can move. So the next thing that we need to do is, if we know all these these particles can have motion, it means when it has motion, it can have a velocity, it can have acceleration, and it can also change in position, right? S. So now, all these strings can have these things. Can you tell me what are the variables that you have and the unknowns that you have for collar A, pulley D, and block B? Now, for this question, let's assume the change in position as, let's take it as symbol X, okay? X. Okay, for this question, we use the symbol X. So tell me, does XA have does XA have a value?
Yes.
What is it?
Yes.
200.
Okay, so XA has a value 200. However, we're not sure where is the initial, where is the final, right? But we know that it moves from K to L. Collar A ni, they move from position K until L. That one we understand. Okay, so what we can do is, So what we can do is we know XA, the final position until the original position is considered to be a value of 200
meter.
mm. Okay, now, do we have velocity of A? Do we have the velocity of A?
Yes.
Yes.
What is it?
300.
300 millimeter per second.
Do you have the acceleration of A? Do you have or not?
Uh,
What do you mean? Yes or no? What do you think is the acceleration of A? Of color A? This is something we do not have, eh? Guys, you please not mistaken. Acceleration of A is equals to 0 only if velocity is constant. Okay? This one only. But right now, velocity of color A is 300 millimeter per second. It is not constant velocity. So we do not know what is the acceleration of A. Acceleration of A is only 0 when the velocity is constant. Okay, guys? All right. Are you okay, guys?
yes.
Okay, now, right. Tell me now what is the information you have for pulley D. Do you have the change in position for pulley D? Do you have for pulley D, this one? This pulley, do you have the change in position, this one? This one, the color purple. Do you have that one?
No.
No. So this one, we do not have that value. Okay. XD minus XD not. This is something we do not have. Do we have the velocity of D?
Yes.
What is it?
75 meter per second.
Okay. Do you have acceleration of D?
No.
Now, the velocity of D, it has what? Constant what?
Constant velocity,
So what do you think the acceleration is?
0.
Yes. Are you okay, guys?
Okay.
Now, okay, now, do you have V naught for D?
No.
Now, when it means the velocity is constant, what do you think the initial velocity would be?
75.
Yes, 75 also. Okay, now going back here, since it says here the velocity of color A is 300 millimeter per second, so what do you think VA naught will be?
Kosong.
Yes, okay, right, it's okay, don't worry. Kita try. Okay, the next is for block B. Okay, so for block B, these are the value we need to find, right? Okay, so we do not know what is the change of position for block B. We don't know what is the velocity of block B, and we do not know what is the acceleration of block B. These are the three things that we want to find. Okay, so we need to find these three things. Okay, all right. So number one, you for this question, number one, you have list out all the variables we have and all the unknowns that we need to find. Okay, and there's one more thing that we need to one more equation that we need to come up with is based on the length of the string. Okay, now, so collar A, it can move up and down. So let's say, okay, let me enlarge this. Let me say that the collar A string, okay, this is string of collar A. Let me name it as XA. Okay, this is the collar string for D, XD, and this is the length of the string for collar B. Sorry, for block B. Okay, so the total length of the string will be TL. So it means the total length of the string will be XA plus XB plus XD. But if you notice, XD ada dua, betul tak? Yang sama panjang.
Yes.
So in front of XD, you must have the value
2.
2. Okay? All right. Okay, good. Okay, now, so what I need you to do is, okay, let's write down all the relevant information nearby so we can see it. So we have just now X, okay, hold on, let me put in black color. So we have, okay, dia tak pekat tulisan ni. Okay, we have XA plus XB plus 2 XD equals to 0. Okay, and then you have the formula V equals to V naught plus AC T. Okay, and then you have we use X, X equals to class. Do you know why I'm using X? Class? Do you know why I'm using X? This is the basic kinematic equation, but right now the S, which is the displacement change in position, I'm using it as X because we have defined the length of the spring as X. So that's why I want to use X. Are you okay, guys?
Okay, madam.
So it'll be what? X equals to?
X naught
Yes. X naught plus
V
not V naught T plus 1 over 2 ACT squared. Okay, and the last one is V squared equals to V naught squared plus 2AC X minus X naught. Okay, all right. Okay, now, oh, sorry, this one is wrong. It's not 0. What it should be? Total length. Okay, now, so XA plus XB plus 2XD, what happens when you differentiate a length that changes? What happens if you differentiate X? It becomes VA, right?
Yes.
And when you differentiate a total length which is constant, it becomes
0.
0. And then if you differentiate velocity, it becomes
Acceleration.
okay. All right. Okay, there you got it. Okay, now have a look at, okay, don't be stressed. This question is actually fun. Take it as something fun and to do. Okay, you have all the information here. Okay, now let's circle and highlight the values that we have and the values that we do not have. Let's use red color. Okay, do we have XA? Class, do we have XA? Tu kat atas tu? Yes or no?
Yes.
Yes. Do we have XB? No. Okay. Now I want answer yes or no. Okay. Do we have XD?
No.
No. No.
No. Okay. Do we have VA?
Yes.
Do we have VB?
No.
No.
Do we have VD?
Yes.
Yes.
Do we have acceleration A?
No.
No.
Do we have acceleration B?
No.
Yes.
Huh?
No. No, no.
Do we have acceleration D?
Yes.
Yes.
Okay, now, based on this information, which one do you think you can find first?
The second one.
Okay, can you please find for me? And give me the answer. Okay, are you doing it, guys? What is the answer, guys? Hello?
Negative.
Negative 0.45.
Huh?
Negative 0.45.
4-5? Betul ke tu?
Dia tukar terus dalam meter per second.
Tak payah, tak payah. Nak dalam millimeter per second. Dalam millimeter per
150.
Okay. So, what is the answer, positive or negative?
Negative.
Okay, so you got VB to be negative 450, betul?
50. Yes.
Yes.
So what do you understand when it's negative 450? It means the block is going
upward.
upwards. Okay, so it's going upwards. Okay, now you have found velocity of block B. Good. Now, what is the next step? So what are you going to do? The next step. Okay, now let's say you want to solve the acceleration now. Okay, you can do anyone. I'm just giving you a guide. Let's say we want to solve the acceleration. We do not have acceleration at B, so it means we need to find the acceleration at A. I need you to respond, guys. Are you responding? Yes or no? At least somebody cakap ya ke tidak ke. Guys, we need to find the acceleration at B, right? So before we do that, we need to find acceleration at A first. Now, based on the information here, acceleration at A, you have change in position of collar A, you have velocity of A, you need to find acceleration A. From these three equations, which one you want to use? Equation 1, 2, or 3?
3.
Okay, why you choose 3? Because you have all the information. Okay, good. Okay, let's use equation number 3. Okay, can you please do it? Use equation number 3, but remember, when you choose equation number 3, change it to VA. VA squared equals to V naught A squared plus 2A acceleration at A, and then it becomes XA minus X naught A. Okay? All right, now what is VA squared? 300, right?
Yes, 300.
Equals to 0 plus acceleration at A, and then change in color A. What is the answer? 200. Yes. So from here, you can get the acceleration at A. So what is the answer?
$225.
Yes, that's correct. It's positive, right? Millimeter per second square. Good. So you've got the velocity of B, you got acceleration at A, so it means you can find acceleration at B, right? Can you find me now acceleration at B?
Yes.
Okay. So what will be the answer for acceleration at B? All you need to do is put it in this equation. A is 225 plus acceleration at B plus 2 and acceleration at D. And what is the acceleration at D?
0.
Yes, this one is 0. So what would you get for acceleration at A? Acceleration at B, sorry.
Negative 225
Yes. So what do you think?
millimeter per second.
So it means that block B is going up or down?
Up.
Yes, good. Okay, now good. So you managed to get the acceleration at B. Now the last part is we need to find the change in position for B. However, for to do that, it means you need to find the change of position of D first. Now, for the change of position for D, which formula you want to use? For equation 1, 2, or 3? Can you guess? Tell me. Tell me. It's okay if you get the wrong answer.
Tiga.
We will discuss. Which one?
Yang ketiga.
Yang ketiga. Okay, now you want to use the third equation to find the change of position of D. But if you choose the third equation, our acceleration at D is 0. So what will happen? You will be, do you understand, guys? If you choose equation number 3, it will be what? VD equals to V naught D squared plus 2AD XD minus X naught D. Now, what happens to the acceleration at D? This becomes 0. So you cannot use equation number 3. Cuba lagi.
Number 2.
Number 2. Okay, now, if you choose equation number 2, it will be XD equals to XD naught plus V naught T plus 1 over 2 A D T squared. So this will be 0. So you are left with what? 2 unknowns. You need to find T, right? Class, can you hear me?
Yes.
So it means the step is step 1, you need to find T first. And how are you going to find T? Using what equation?
Equation 1.
Yes, equation 1. However, for equation 1, because the time is same for pulley A, for collar A, for block B, and for pulley D, you can use equation 1 for others also. For example, V equals to V naught plus ACT. Which one you want to use the equation for? You want to use for collar A to find T, or you want to use pulley D? Which one?
Collar A.
Yes. Why cannot you use pulley D? Because acceleration is 0, right?
Yes.
So we use for collar A. So VA equals to V naught A plus AC, acceleration at A multiplied by T. So from here we can find T. So can you find T for me? Can you find what is T for me? What is the answer for T?
1.333 second.
1.33
Ah,
Okay, betul? 1.333 seconds. So from here, 1.33 seconds, all you need to do is put it in the equation to find the change in position. So if we bring this down here, xd minus xd naught equals to v naught t. V naught ni ialah untuk d ya. So what do you get? What's the answer? V naught d is what? 75 also, right?
Yes, 75.
Times 1.333. So what do you get?
99.98.
So 100 lah. So that is the answer for XD. The change in position for pulley D. That is the answer. So from there, what you can do is you can find the change in position for block B using this formula. So you put here, okay. All right, now XB, oh sorry, no. Okay, XA minus X naught A, okay, plus XB minus XB naught plus 2, alamak tak muat, XD minus SD naught equals to total length equals to 0. You know why 0? Because X naught A ni yang ada initial position ni akan bawa sebelah. So dia jadi kosong. Okay? So what is our XA minus XA naught? This one is 200, right?
Yes.
And then XB you nak cari. And then what is XD? XD naught yang you cari tadi 100, betul? 100. Oops. So what is the answer for change in position for block B? What is the answer? What is the answer? Hello, cepat. Dia senang je.
Negative 400.
Yes, that's correct. So what does it mean? What do you understand by negative 400? It means the block B is going to go up. So when it goes up, the length of the spring will be shorter, right? The length, because when collar A is going down, the length of the string is gonna increase. What happens to block B punya string is gonna be shorter. That's why there is a negative value. Understand?
Yeah.
Okay, all right. So you have already got the answer for all. Okay, all right. So this is a very good exercise that we did together. It's quite complicated. However, if you understand the concept by reading the question carefully, identifying the correct unknowns and the variables that you have, and then looking into the correct equation to use, it will be easy. Okay, okay, guys. All right, so that's good enough for today's class tutorial. So for next class, we're gonna do curvilinear motion. So what I will do is I will stop the recording and upload this example in YouTube as usual. So for those who require looking at the video again and understanding it again, can spend their time to look at the video. However, please do not lump sum all the videos that you need to repeat to look in the last minute. If today is the class and if the video has been uploaded, by today you should finish it. If you need to work smart, not hard. Okay, working smart means, what is working smart? Can anybody tell me what does working smart means? Hello guys, can you tell me what is working smart means? Arif, what is working smart?
Efficient.
Okay, good. Okay, so you need to work efficiently, okay. Apa? So I hope after this, if you feel that you lost a little bit, you can always look back at the recorded video, or you can always ask me questions. If I forgot to reply your question, it means that maybe your message has gone down right at the bottom, and you need to remind me your question. Inshallah, I will try to respond and reply. Okay? All right. So I'll stop for today's class, today's recording. Okay. Anybody has any questions?